Yes, sir. We are in live now.
Yeah, sure.
Just a minute. I'll check. Live has been. Yes, sir. We can start.
Yeah.
So, good morning to everyone present here. On behalf of the Department of Computer Science and Engineering with specialization in cybersecurity, from RMK Group of Institutions, it gives me immense pleasure to welcome you all to the Generic Talk Series number 37. Today's session is titled on Engineering India's Future, Core Competencies Driving Energy, Infrastructure, and Digital Transformation. This theme is both timely and significant as India's stands at the transformative phase where energy, infrastructure, and digital technologies are converging to shape the nation's growth story. We are deeply honored to have with us our distinguished speaker, Mr. Venkatesan NL, Sir, Managing Director of Sri Venkateswara Consulting Engineering, Chennai. So now I would like to welcome Dr. S. M. Udeshankar, Sir, Professor and Head from the Department of CSE Cyber Security, to deliver the welcome address. Please, sir.
Thank you, ma'am. Honorable Chairman, sir, respected Vice Chairman, sir, esteemed advisors, respected principals, respected deans, academic coordinators, heads of various departments, distinguished resource person, Mr. Venkatesan, esteemed faculty members, and my dear students, a very good morning to one and all present here. It gives me immense pleasure to warmly welcome you all to Generic Talk Series 37 organized by RMK College of Engineering and Technology. Today's session focuses on highly significant theme, that is engineering's India's future. So India is presently undergoing a major transformation through large scale national initiatives and investments in energy, transportation, manufacturing, smart cities, infrastructures, and digital connectivity. The Government of India is actively promoting infrastructure expansion, renewable energy projects, industrial corridors, and digital developments through various schemes and funding programs. These initiatives are creating enormous opportunities for engineers, especially those with a strong core engineering knowledge and practical skills. Hence, it becomes essential for our students to understand not only theoretical concepts but also how engineering knowledge is applied in real national projects. So we are greatly honored to have with us our distinguished speaker, Mr. Venkatesan Sir, Managing Director of Sri Venkateswara Consulting Engineers and a former professional from Bell. So BHEL, with his rich industrial experience and direct exposure to infrastructure and engineering project, he will share valuable insights on government funding patterns, investment opportunities, and how engineers can contribute to nation building through core engineering sectors. So I am confident that today's session will broaden our students' perspective, help them understand the scale of national development projects, and motivate them to strengthen their engineering fundamentals and career readiness. I take this opportunity to express my sincere gratitude to our management, chairman, vice chairman, advisors, principals for their continuous encouragement and support in organizing such knowledge enriching programs. I also thank our deans, academic coordinators, heads of various departments, faculty members, and students for their efforts in making this program successful. Once again, a warm welcome to our respected resource person and all the participants to this session. I wish all a very informative and inspiring learning experience. Thank you.
Thank you, sir. Now it's my privilege to introduce our esteemed guest speaker, Mr. Venkatesan NL, Sir, a highly accomplished engineering, procurement, and construction professional with over 17 years of extensive experience in India's power and infrastructure sector. Mr. Venkatesan sir served at Bharat Heavy Electrical Limited, a Maharatna public sector undertaking where he held key leadership roles including construction management. During his tenure, he led multidisciplinary teams in executing large-scale power plant and substation projects across India, including substations up to 765 kV. His expertise spans civil, mechanical, and electrical domain with hands-on experience in erection, testing, commissioning, and contract management. He has successfully contributed to major projects for organizations such as TAN Transco, PGCIL, NMC, and others. Notably, he played a crucial role in revamping stalled EPC projects and ensuring successful project completion, earning appreciation from top management. Academically, he holds a master's degree in electrical engineering from Delhi College of Engineering with distinction. He is a GATE qualified engineer and has completed advanced certification from Indian Institute of Science, Bangalore. His master research focused on applying genetic algorithms to optimize power system operation. Currently, he serves as the managing partner of Sri Venkateswara Consulting Engineers, providing consulting services in power, oil, and gas and infrastructure sectors. He is also a board of studies member at Anna University, contributing to engineering education and curriculum development. With strong leadership, project management expertise, and a passion for nation building through infrastructure development, Mr. Venkatesan sir brings a wealth of knowledge and practical insight. So please join me in welcoming Mr. Venkatesan sir. Over to you, sir.
A very good morning. Very good morning to all of you. Firstly, I would like to thank Honorable RMK group of institutions, RMK College of Engineering and Technology, and their good old engineering college, RMK Engineering College, and other education institutes of RMK group. Thanks to the management. Second thing, respected principals, sir, deans, sir, learned faculty members. And I always say the future India. Future India means the young engineers who are going to become the graduates in this year or the students who are pursuing their engineering studies. So first thing, very good morning to all of you and thank you very much for your opportunity. This particular lecture, what I would like to say is, I want this lecture to be an eye-opener to the young engineers, and moreover, it will show the opportunities they have in the core engineering and application of the present latest technologies, data analytics, artificial intelligence, or whatever it may be, how it can be applied to the engineering discipline, that is in core engineering. Okay, so this particular lecture, I want it to be an eye-opener for all the students, and moreover, they can shape their career, how they can choose their career opportunities once they complete the graduation, as well as what are the opportunities they have in India as well as in abroad. So I can give some glimpse of it, and what is the future investment plan of India, in which are the sectors they are investing, and what are the job opportunities created by the Indian government, moreover by the private utilities. Those things we will discuss today. And I hope this, by the end of this session, students will get the motivation to develop themselves. Yeah, first let me, if this topic really I like very much, in engineering India's future, core competencies, driving energy, infrastructure, and digital transformation. Actually, my first slide itself, I have clearly kept the investment plan by GOI, Government of India, and private utilities. See, there are various Government of India initiatives. First thing, we must know that in which domain it directly impacts the society. As we all know, we are discussing about the carbon credits or zero carbon. India is marching towards zero carbon mission by 2070, but still we have a lot of plans by 2030, 2037, and we have a lot of plans about it. So first thing is, we have large amount of investments in renewable projects. Renewable projects means this solar, wind, and hydro. Apart from this, thermal-based plants, but still we have thermal-based plants also. There are a lot of investments. Recently, we got plenty of orders. That is, our engineering Maharatna company got plenty of orders for the thermal plants also. Those things also we will discuss. So first aspect is renewable projects. Second thing is batteries, battery energy storage systems, and EV charging stations. Battery energy storage systems become crucial or become vital because we need to store the energy in the form of a DC source. We must store that one. Then only we can convert it when the sunlight is not available. During that time, we can, by using the inverter, we can convert it and we can utilize, we can tap the power. So battery energy storage system or battery technologies are very much developing. During this situation, I would like to mention one firm name also, QuantumScape. That is a US-based company. They are into a different technology. That is, there are plenty of new technologies are coming out. Lithium-ion based is now prevalently being adopted, and plenty of other technologies also coming up. Okay. And second thing is metro projects and high-speed trains. Both I have included. See, metro projects, as we all know, that you can, in Chennai itself, you can see there is a Chennai metro rail. If you go to Bombay, Mumbai metro rail, Bangalore, you can go to Bangalore metro rail, Delhi metro rail. Many places now, even though there are metro projects are commissioned, they are widening their infrastructure. That is there are a lot of investments into that. Okay. And high-speed trains, bullet trains and loop technology, hyperloop technology, that particular slide also I will show you. So in this area, government is keenly investing. Second thing is data center. See, in those days, say some 30 years before, or even 25 years before, or 40 years before, we will be having a power plant. From there, the power will be delivered to the end users. End users means the industries or the factories or the residential complexes, malls. These are the utilities. Okay, these are the end users, and utilities will be the power plant or power source, whether it may be a conventional or non-conventional one. So these data centers now become a crucial part as a co-location center, or the data being stored in the in a center one place. That is, from there, through high-speed internet, the data will be shared for the respective companies. We can have a storage of the data, okay, in that particular center. From there, through the high-speed internet, we can retrieve the data, we can process the data there. So that's why the data centers are very much booming, and there are plenty of investment by the government of India, as well as you all know very well that now in Vizag, Google company is investing. Google, please remember, US-based company, Google company is investing 88,000 crores. Can you imagine? 88,000 crores is being invested for the data center setup. It will transfer data across Asia. Okay, even to the neighboring countries also, we will be sharing the data. It will be set up in Vizag in Andhra Pradesh. Okay. And second thing is conventional power. See, conventional power means the steam-based steam turbines, that is the thermal-based power plants, coal-fired boilers. Coal-fired boilers also, there are different varieties are there. One is lignite-fired, that is our Neyveli lignite plant is there. And apart from that, we are having a normal bituminous or anthracite coal-based, that is our coal-based plants, and nuclear-based plants also there. Now there are a lot of investments in nuclear-based plants also. That also I will show you in the respective slides. Next is why we need this much of power. That is most important thing. Why we need this much of power? Because as we say, the data centers needs critical power and cooling solutions. Why? Because the fast processing chips, it requires cooling, enough cooling, and 24/7 cooling services are required. For cooling, you need lot of power. Okay. So for this, you need that is the power demand got increased. So apart from that is present, Indian infrastructure grid is having some 4.5 lakh megawatt or 5 lakh megawatt. Another, say, in a span of another 5 years, we have to add minimum 3 lakh megawatt. Can you imagine? Almost double the power we need to bring into the Indian grid. So the amount of investment, you just imagine. This HVDC, why I have mentioned is bulk power transmission. Okay. In now renewables are getting developing in a very unimaginable manner. See, in Gujarat, we are going to have that is our one of the private utilities. Say we can say Reliance Power also. They are going to make 1 gigawatt solar renewable project in Gujarat. Okay, 1 gigawatt. That means almost 100,000 megawatt. Can you imagine that much of solar potential we are having? So that needs to be transmitted. Transmitted means normal 765 kV line or 1200 kV line also in future we will get. that is not sufficient for us. So, and moreover, we have to minimize the losses. So in that case, this HVDC technology is vital, and HVDC power transmission is the viable solution. So there are a lot of investments in HVDC also. And second thing is, so another thing is CCUS. This carbon capture, storage, and utilization technologies will play a vital part in the upcoming future. And consultancies like Worley Parsons, okay, Worley, they are investing on this. In future, actually, this will be advised where there is a direct emission of the carbon dioxide. Where there is a direct emission of the carbon dioxide, it comes from the thermal-based power plants. Okay, thermal-based power plants, steel plants also, where this carbon dioxide is directly getting emitted. There we are, that is, new technologies are being adopted to capture the particular carbon dioxide, and how to utilize it also, or how to recycle also. That technologies are getting developed. There are a lot of investment happening in that particular area, CCUS. And another thing is this, we are all now today, we are all talking about the AI, okay, and we are talking about the data analytics and Internet of Things. All these things we are discussing. So one thing I would like to say, 30 years before, 40 years before, the statistical process control, SPC, we call it as statistical process control, is being applied by all the manufacturing plants, especially the automotive sector, with the help of the Indian Statistical Institute, to augment their production process by minimizing the scrap. Okay, that 5S principles or whatever it may be, they have applied it. They used to say 0 ppm. What is meant by ppm? Ppm is nothing but parts per million. Okay, so everybody is having their own target or objective, companies, and they accomplished their production by applying the total quality management. But nowadays, this data analytics, getting the data directly from the machine. Okay, suppose if you are having a manufacturing setup, you will be having machines with plenty of machines. Your bending machine you will be having, grinding machine you will be having, machining processes there, material preparation that is shop is there, MP shop we call it as. Okay, how do you plan, and how, when you get the data directly from the machines, by seeing the data, you can do the analytics. With the help of the analytics, and if you are inferring the results, you can improve the production process. So this is one such domain. I'll also show you one of the paper clippings. Now, the big companies like Google, Meta, Microsoft, and then NVIDIA, these companies now are, so how we can apply this application? Application plays the crucial part, and thousands of crores are being invested on this particular domain. Okay, this is another thing I will definitely discuss. And another thing is this extensive expressway projects under Bharatmala. Actually, now for freight purpose as well as for the passenger movement or cargo movement, lot of expressway projects are being, national highways projects are being developed under the scheme, under Bharatmala scheme. And another thing is green hydrogen mission. See, this green hydrogen now becomes a vital part, especially in terms of the power generation. Okay, because green hydrogen, as in the name itself indicates, you will be getting the carbon credits. So here also there will be a lot of investment by the government of India as well as from the foreign companies. And the last but not the least, India semiconductor mission, that is ISM. This is a very huge investment in this particular domain. Many people are opting for the VLSI courses in their specialization. So IC designing as well as its fabrication. In those days, of course, we used to design the ICs. We used to give the design to the other countries for making it fabricated. Now the fabrication technology itself is coming up in India, and we are self-reliant. We call it as a self-reliant by this Government of India initiative. There are plenty of investment in this. One such investment is Tata Group is already investing in semiconductor fabrication, and one more company is HCL and Foxconn in Uttar Pradesh. They are investing. That also we will discuss. By this semiconductor mission, we can be self-reliant. Why Taipei is such a powerful country today? If Taiwan factory is getting closed, the production of China, even the production of China, production of India, production of US, all the automotive sectors in other MRIs, imaging systems, all these companies have to go for the shutdown because they are having the semiconductor fabrication. That much huge factory is set up. Okay, those things and all we will discuss. Now, let me go to the first thing, renewable projects. Let me not get into each and every slide. I'll just give you the glimpse. I will share you the slides to you. You can go through it. These are based on my experience as well as the legible information. Okay, this is nothing because we are, as of now, after getting resigned from BHEL, I am heading this firm as a managing partner in this Sri Venkateswara Consulting Engineers. We are working with some of these companies also, so I know the quantum of investment in these renewable projects. Okay, now why I am talking about this so much of investments is, so we are having that is always this core competencies. Core engineering means always we know the civil engineering, structural engineering, mechanical engineering, electrical engineering. Even we can, to some extent, we can also include this instrumentation engineering. Of course, communication technologies are getting developed in a very faster way. But at the same time, this particular core engineering plays a vital part. As we are having this much of investments, do we have the engineers for that? Do we have, that is, can the market can meet the demand? Whether the engineers can meet the demand of the market requirement? That is my major objective in sharing this particular slides. Okay, so this much of investment is there in core engineering. So definitely nowadays I encourage the students, that is upcoming students must learn the core engineering. They must take the core engineering streams in the colleges like civil, mechanical, electrical and all. Once if you study this one and if you start applying the data analytics or by using Power BI in the data analytics in this particular core engineering field, your market value will increase, or your employability will increase, the society will get benefited, country will get developed. See, even if you apply the AI technologies or the data analytics also, you must be in a position to infer it. If you want to infer it and if you want to optimize the performance of the plant or the production unit, you must have the domain knowledge. So that's why this core competence is important. At the same time, to improve the present technology, that is the data analytics or AI or these things, we must learn. It is mandatory it must be included in all the engineering curriculum. At the same time, the domain knowledge also must be prevalent. Okay, now you can see one simple thing. I'll just tell you, as I told this, you can see that over $360 billion by 2030 for 500 gigawatt renewable capacity, including $150 to $170 billion for transmission and storage. That I'll come in the next slide also. So this Kavda Renewable Energy Park in Gujarat, Kavda Renewable Energy Park in 30 gigawatt. It is by the our Honorable Adani Utilities Group. Okay, they are, so all these people in Gujarat, there are plenty of investments in renewables. Even in Tamil Nadu we are having, in Maharashtra we are having. Renewable means it includes wind as well as solar and hybrid also. Okay, so wherever this solar system is being implemented, their battery energy storage systems are very, very important. Okay, battery energy storage systems are very important. Okay, now next, hydro. See, we all talk about the water. Water is an excellent resource. God has given this particular water resource. With this, we can tap enormous amount of power. Okay, one such is, I'm just clicking it out, 6.4 lakh crore plan for 76 gigawatt from Brahmaputra. I'm just clicking this. I'll just try to see whether this LinkedIn page is getting open. Yeah, it is getting open. You can, I hope this particular screen is visible for you. One second. It's actually a 6.4 lakh. It's actually a 6.4 lakh investment. Okay. It's actually a 6.4 lakh crore plan for 76 gigawatt from Brahmaputra. Okay. One clipping is also there. I will share it. The most important thing is, as we all know, now China is constructing a very big dam in that northeastern area. Okay. So whatever because Brahmaputra origin is not from India, it is from Tibet, but it flows through India, China and all. So once they construct that dam, similarly, Indian government is also having a plan to construct dam in our particular India to tap the particular 76 gigawatt of power from the clean energy, from the hydropower. from the Brahmaputra basin. That's investment itself is rupees 6.4 lakh crore. Can you imagine that much of amount of investment there? But it is not for 5 years or 10 years. They are planning to tap this total 76 gigawatt power from 2047. But next 5 years they are having a plan for say some few megawatts, that is 10 to 20% of it. So there are plenty of investment in this particular renewable sector. Next, battery energy storage system. As I mentioned you, there are plenty of companies now investing on this BESS, because in future, even though we will be having a solar power, unless you store it, you cannot retrieve it during the peak hours, during the peak load time. Okay, so that is most important thing. There are some of the companies' names also I have mentioned. That government incentives include 9,100 crore in viability gap funding for 43.2 gigawatt hour of projects. So imagine the amount of quantum of investments. Okay, India plans for 50% non-fossil fuel capacity by 2030. What does it mean? It means that, as I told you, that we are approaching towards the green mission by 2070. But by 2030, we are planning to achieve 50% of the non-fossil fuel. Non-fossil fuel means non-coal based. So 50% we are aiming by 2030. So definitely, once if you are tapping the renewables, then definitely this battery energy storage system we must develop that one. Batteries must develop. So lithium ion battery is one most important chemistries. Now sustainable and recycling techniques also are being developed. These application areas, key uses include renewable energy firming, grid stabilization. This grid stabilization is a very important topic, and managing peak demand, as I mentioned you before. Then battery manufacturing companies in India, as we all know that right from childhood, we know about this Exide. And Amar Raja is also doing well, and we have other companies also. So there are a lot of investments. Once there are a lot of investments or a lot of budget is being allotted, we need engineers in that particular domain. So engineer who can contribute for this one? Definitely electrical domain engineers are required in this particular battery energy storage systems. In hydropower, I told 6.4 lakh gigawatt. Then you see the amount of civil infrastructure you need. You need to construct dam, you need to construct penstocks, you need to construct the powerhouse. Civil, structural engineers, mechanical engineers, E&M package is huge. I have seen the hydro turbines, 75 megawatt type hydro turbines I have seen. So these turbines rating will be very high. So definitely there will be a demand for the mechanical engineers, electrical engineers. So we must concentrate on that. At the same time, you try to apply the data analytics in this particular domain, your market value will start increasing. Okay. Now next, metro projects and high-speed trains. As I told you before, these metro projects are now getting developed like anything, because to commute the people, main thing is it takes a lot of time because of the purchase of a lot of vehicles, that is 4-wheelers, 2-wheelers in the roads. The traffic is getting more. So everybody wants to transport. That is, in metro, you will be having a very clean environment, and you can reach the destination in time also. So that's why there are plenty of investments being deployed by the government of India in metro projects. And where are the engineers? We have to build the civil infrastructure. So definitely civil engineers are required, structural engineers are required, and trains, all are electric trains. Okay, so definitely that linear induction motor technology, signaling and telecom technology. So all these things we need core engineers. Okay, now high-speed rail projects in India. National High Speed Rail Corporation Limited, NHSRCL, the first high-speed railway corridor between Mumbai and Ahmedabad. See this, there is one separate organization is being formed, that is National High Speed Rail Corporation Limited. It actually now they are marching towards this 350 kilometer per hour. So please imagine the quantum of investment in that much high speed we are talking about. So there is a separate corporation is also there. They also need engineers in core domain as well as in IT. Okay, I'll come towards that IT part and how we can apply it to the core engineering also. I'll come towards it. Okay. Another most important thing is Hyperloop technology. I just gave a glimpse of it. You can also search in Google. You will get plenty of things. IIT Madras having a tie-up with Indian Railways, especially for this Hyperloop technology. You see here is a proposed high-speed transportation system featuring pods that travel in low-pressure vacuum tubes at speeds up to 1,200 km per hour. Can you imagine the speed? Our Delhi, from Chennai to Delhi is totally approximately 2,000 to 2,100 kilometers. If the train runs at this speed, we can reach Delhi in 2 hours. So morning you can go to the office in Delhi and evening you can come back to Chennai. It is going to happen in the future, maybe in a decade time. Okay, that is in another 10 years or another at least 12 years, at least one successful train will be run between Chennai and India, Chennai and Delhi with this Hyperloop technology. So see the amount of investment in this. I have written IIT Madras is actively developing India's first Hyperloop test track in collaboration with the Indian Railways, aiming to accelerate adoption and testing. Okay, so please imagine that quantum of investment and the amount of engineers requirement in that. Okay, see, whatever the technology we study and whatever the engineering curriculum we study, unless we sell ourselves in the market, then we are not achieving the full potential of it. So we must know the demand of it, then only we can equip ourselves. Skills are most important. Then coming to the data centers, as I told you before, now data centers, now there are plenty of scope in data centers. So when we talk about data centers, there you will be definitely, as I told, it's a co-location center, storage area networks will be there. This data center, it will store the data of the companies or the even from the independent also, that is from the mainly from the corporate companies. It can store the data and it can process it, and it can provide when the company needs the data, it can share also through the high-speed internet. Okay, so there are a lot of investments in this data centers. As I mentioned, this Google is investing 88,000 crores in Vizag project. Why that particular data center has not come to Chennai? Because through the sea we have to lay the cables. So already in the Chennai zone, the cables are being laid. So that's why they have chosen the place in India for Vizag. There we have the port connectivity also in the sea. You can, because we can, that can be a hub for the nearby neighboring countries like Singapore, Malaysia, Philippines, and then even for New Zealand also they are planning to give the data through that particular data center. Okay, so that much amount of investment is there. And one thing I would like to say in this, data centers also normally rated in terms of megawatts. It's not the only the powerhouse. It's not the only the thermal power plant or hydro or nuclear, whatever it may be. It's also about the data centers also rated in megawatts because of their highly dependence on the critical power and cooling requirements. So your megawatt rating quantifies the total power available to run high density IT equipment, cooling, critical infrastructure, determining the facilities overall support workload. So imagine once the data center is getting developed, definitely you need a power plant to power up the data center. So definitely the power plants are going to be increased, whether it may be in the terms of renewable or in terms of the conventional energy. So the requirement of the core competence getting more and more. At the same time, data centers, storage area networks is getting developed. The optical fiber communication is getting developed. The processing speeds of the processors. So the architecture, and most important thing is security. The data security is very important. The cyber security is getting very important. So that also investment is getting multiplied. Now this one, Google Invest Data Center, I have just mentioned you. The press clipping also I have kept it. Okay, they are going to partner with Adani Connex. Okay. Next, cyber security. Data security, why it is very important is, as I mentioned you before, even corporates are going to have their data in the co-location center or the data center. So they need security for their data, that is privacy for their data, because through the data only they can do, they can operate their entire firm. So you can see here, it aims to ensure confidentiality, integrity, availability of information, reducing threats like ransomware, phishing, malware. See, effective security requires a layered approach. They have given a lot of things: network security, cloud security, application security, information security, end user education. So through these particular verticals, we can ensure the cyber security. See, one basic thing, what we can do is normally, whether it may be password is the most simple thing which we call it for a security. So the password itself is that's what this 80 by 20 Pareto principle is being used in this cyber security. 80 by 20 rule in cyber security is there. I'll just show the investments in the cyber security. Investments in cyber security is also huge now. So that is being separately taught in the engineering colleges as a specialized courses. Okay. There are opportunities in that. Along with the computer science branch, this can also be learned. Second, investments in conventional thermal and nuclear to meet base loads. See, why I have written base loads is, see, data center means if it is 500 megawatt means 500 megawatt load I need to provide. See, this is very difficult to provide by using the renewables. Okay, that's why we are going for the BESS. But that's why one of the clipping also I will show you. In US, in the United States, we all know, even though it's an advanced country, they themselves are thinking once if we develop this much of data center, then parallelly we need to run the old thermal power plants. We need to extend the life cycle by another 5 years or from 7 years, and we need to invest it into also in the nuclear technology for power generation. Okay. So with this, that is India is investing almost 2.3 lakh crore investment, 2.3 lakh crore investment by 2027 to 28, with investments projected to double to meet rising energy demand. That much of demand is getting increased because of the development in the data centers, development in the high processing chips as well as in the storage capacity. As the IT infrastructure is getting developed, the core infrastructure also must get developed to support that particular IT need. Okay, so that's why this investment in conventional is going to double. The total investment expected to reach 2.3 lakh that is lakh crore. And there is significant amount of private sector participation is also there. Private utilities are also investing to harness the conventional resource. Okay, now government also has given some of the approvals to set up the nuclear power plants by the private utilities also. Earlier in those days, only the government was having the government of India firms having the rights to set up the nuclear based power plant. Now the permissions are being given with some restrictions to the private players also for increasing energy demand. Then you can imagine the quantum of investment in nuclear sector also and the requirement of the core competencies, core engineering. Okay, that is most important. Okay, now this one, investment in conventional thermal and nuclear to meet base load. Now I'm just clicking this one. Okay, you can see here. Government draws up 19.3 lakh crore plan for nuclear power. Can you imagine that particular link also I will share you. That much amount of investment is there. Okay, government draws up 19.3 lakh. So can you imagine when that much of investment is there, then definitely there will be a lot of opportunities. Okay. Next, this particular thing, our honorable President of US, Donald Trump, sir, he has written that looking to restore coal plants as America's grid buckles. So this is a very important thing. These clippings I have really kept it to show the importance of the thermal power plants. You can just see here, unleashing American energy dominance. Okay, Trump admin looking to restore coal plants as America's grid buckles. See, if you read this one, they have clearly mentioned it is purely because of the requirement of power for the data centers and the fast acting processors. They need to run the old thermal power plants for another 5 years so that they can, and moreover to invest in thermal also to meet the country's energy demand. Then you can imagine the demand of the core engineers. Okay. And this also you can see. Most coal-fired power plants will delay retirement to feed AI boom. So when there is a artificial intelligence boom is there. Energy secretary in US itself says that we need to provide adequate power for powering up these data centers and other things. So these are the clippings, and it shows that how important it is to develop the core engineering competence. Now let us move to the next slide. HVDC bulk power transmission for renewable evacuation. You just see India is investing 9 to 13 lakh crore investment. Can you imagine? See, once if you are investing that much amount in particular domain, then you can imagine the number of engineers we require to meet that demand. Not only electrical engineers, you need civil engineers, you need mechanical engineers. In the electrical also, you need design engineers, production engineers. One more clipping also I have. In Brazil, there was a blackout some 2 months before, because they finally identified in those days there were production engineers with the very adequate knowledge to plan their electrical infrastructure. Okay, nowadays what happened, because of the shift, they could not, that those types of skills are not getting transmitted to the younger generation, that is transformed to the younger generation. That's why I have kept the objective for my firm itself as national development through knowledge transformation. Okay, so that is most important. Whatever be the field it is, whether it may be core or in the IT sector, always the knowledge transfer must be there from the experts to the engineers, experts to the budding engineers or to the field level operators. Okay. Now, this HVDC, once if that is one very respectable project is being going on now for this Kauda renewable energy power evacuation, 30 gigawatt, as I mentioned. Their HVDC plant is set up by our private utility, Adani Utilities, and this project is being completed by the KEC. So one thing I would like to tell you, whenever there is a utility, there will definitely be an EPC company. EPC means engineering, procurement, and construction company. To guide that EPC company, there must be a project management consultant. Project management consultants are many project management consultants are there. In India also there, in abroad also there. In India for energy sector, especially in the oil and refineries field, we are having Engineers India Limited. They are guiding that particular thing. And for a power domain, we are having Tata Consulting Engineers, and we are having for fertilizers and our Project Development of India Limited. So in the US level, we are having Atkins. Okay, and then a Floor Daniel, and then Bechtel. Bechtel is a very vast engineering company. They are handling $1 million projects all over the India and abroad. When we talk about HVDC technology, Hitachi and Siemens and as well as GE are world level players. So you see the amount of investments in manufacturing the HVDC technologies, high power semiconductor devices, converters. So all these things you need core engineers. At the same time, for any core engineering, you need to process. You need to process the data. You need to process the particular plant performance. So definitely high processing speeds, that is operating systems or the semiconductor chips are being required. So that involves a lot of investments in the IT sector also. Okay. So now central transmission utility in India is Power Grid Corporation of India Limited. They will be the central transmission utility, but nowadays to meet the demand, private utilities are being given some of the permissions. Now capacity expansion, can you just imagine by 2030, 2342 gigavolt ampere. So that much amount of transmission capacity is being required. So that much amount of transformers are being manufactured. Can you? That's why we are having foreign investments also. Tibia, one Chinese transformer manufacturing firm is there, and Hitachi also is having a manufacturing firm in India for transformers. So when the manufacturing sector is getting improved, mechanical engineers are required. For design, electrical engineers are required. For constructing the factory, civil engineers are required. For optimizing the performance, we need data analytics per team also. So definitely computer science engineers are required, and networks is required. We have to store the data in the particular data center. So computer science engineers are required. So it's a cycle. Okay. So you cannot depend on only one technology. So my advice is, see, when you now, after getting 17 years of experience in BHL, I proudly say, now I am neither an electrical engineer, nor a mechanical engineer, nor a civil engineer. I am a power engineer, or I am an EPC project manager. I can handle the projects right from the excavation. I can manage the project. I can handle that project. That confidence is most important. So nowadays for the engineers, what I conclude is, you must be in a position to understand the basic drawings, whether it may be civil or mechanical or whatever it may be, and basic aspects of welding. Okay, and then basic scheme checking. At least you must be in a position to know what power we are getting, what protection voltages are being used in the power plants, in the refineries. Okay, and how to tap that particular protection voltages, and how the optical power communication systems is being developed. See, we all talk about the OPGW, that is optical ground wire technology, OPGW technologies. It is being used in all the plants, not only in the power plant, now in the substations, power plant, from remote, from in my house, I can operate. That is not in my house. At least you can say in a centralized load dispatch center, I can operate a power plant breaker. I can operate a substation breaker. Okay, that much of now communication is being developed. The data is being transmitted. So you can imagine the importance of it. Okay. Next, ongoing HVDC project, many things are there. Now General Electric also has got one project from Adani, and Hitachi and BHEL got an order from Power Grid as well as from Adani. It is all going on. Okay. So once this what you call this large amount of HVDC converters, that is this power semiconductor devices are getting developed, then definitely power quality issues will arise. This power quality definitely there will be, it will be a one of the research topics in the future. Already plenty of research is being going on. That is also one area it will be looked into. Now, this carbon capture, storage, and utilization technologies, as I told you, definitely there will be a carbon dioxide emissions. That is, these emissions are mainly from the thermal power plants, from the vehicles, even from steel plants, from refineries and all. Now, how to capture that one? That technology is this. That's what CCUS means, carbon capture. Carbon capture. First, we must capture that carbon dioxide. Then we must be in a position to store it properly without getting exploded or without getting mixed with the atmosphere. And how to utilize that one? For this one, the investment is getting huge by the Indian government. I'll just show you. You can see here, investment in carbon capture, utilization and storage is accelerating rapidly, with India recently allocating 20,000 crore over 5 years in 2026 to 27 budget to scale technologies heavy industries. So you can imagine the quantum of investment, 20,000 crore. Can you imagine? So for this also you need core competence. How the carbon is getting captured. So you can see one is membrane separation. It uses special membranes to separate CO2 from other gases. Another thing is liquid solvents such as amines to bind CO2, solid metal that attract and hold carbon dioxide. Okay. So you imagine then once if you what you call the observe that one carbon, once you capture that one, then you need to, that is where this carbon is getting emitted, as I told, in the power plant, steel plant, cement plant and all. Okay, global investment is almost 10 billion in 2023 with over 350 projects in development. Key focus areas include industrial decarbonization, creating carbon dioxide markets, and bridging the gap between pilot projects and commercial. They want to bring it into the commercial deployment. That is most important. Whatever we do, as I told, even us also, our skills must reach the market. Then only the society will also get developed. At the same time, your profit also gets improved. Okay. So you see the massive future investment is $510 billion. Can you imagine, needed to meet the net zero goals by the total world. So this is also one of the emerging technologies where engineers need to study. That's what core competence is required. When we talk about the membranes, what type of membranes, what type of materials, how it can attract. Okay, now how we can store it, that is also important. Okay, and then how we can use it. Use it means that is storage, injecting carbon dioxide captured into deep geological for depleted oil and gas reservoirs, where we are already taken the oil from the ground, okay, where it is completely depleted, where there we can store this particular captured carbon dioxide by reducing overall greenhouse emissions. Okay, how we can utilize it, that is also most important. Converting captured carbon dioxide into value-added projects such as chemicals. We can generate some of the chemicals, fuels, or construction materials. By that way, we can utilize it. So these are the one of the emerging technologies where the investment is more and engineers are required. Next, application of data analytics in manufacturing, power, education, healthcare. Okay. This is, as I told, all IT engineers, all computer science engineers must enhance their skills in this particular domain. See, one paper clipping I'll just show you. One paper clipping I'll just show you there. 1 second. See, this one is a very good slide. You can just see, I just zoom it and show you. Gen AI use case adoption trends across industries. In which are the industries, how this particular generic AI is being used. Application is most important. You can see here, communicate this very strong, medium, weak, those things are. You can see the manufacturing and natural resources. It has huge applications across different verticals. And communications, media, and service, banking and securities, this data securities or cyber security, whatever you call it as, manufacturing process, it is being applied. Healthcare, it is being applied. Okay, oil and gas also it is being applied. Education also in RMK also we can apply it. That is in your college also we can suppose if your top management wants to see in the dashboard itself, we can show in the mobile dashboard, we can show that is what is the total fees being paid by all the students, what is the backlog, or who is the topper, what is the total ranks, your university, that is in the university top rankers who are there, and student metrics also can be formed. So everything can be viewed in the dashboard. Okay, so this data can be applied this way also. And second thing is this particular PDF I would like to show you here. Cursor. No. This one I want to. Yes. Yeah, you can see this one. Okay. AI's next investment cycle belongs to applications. This is a paper clipping. This particular paper clipping came on February 1st week, okay, in the editorial column. It is very clearly mentioned now the infrastructure is being developed for the data centers, all those things. But how we are going to apply? All profits will come from real applications. It is a very good editorial column. You please, I have just shared it in the slide also. You can go through it. It shows how the AI's next investment cycle belongs to the applications. All major companies, okay, are focusing now on how to apply the AI into manufacturing, healthcare, education, many things. Okay, so this will be one very good topic to listen. And extensive expressway projects under Bharatmala. See, as I told, there are a lot of expressive, that is express highways, economic corridors. It is being deployed across India for 9,000 kilometers. Can you imagine? With this, 44 major corridors are identified. One is Mumbai, Kolkata, Surat, Nagpur, and many locations are there. They have given. By 2025, late 2025, almost 21,000 kilometers of water phase 1 has been constructed. You imagine, and projected cost for phase 1 was 5.35 lakh crore. Can you imagine the quantum of investment in the highways project? So how much civil engineer is required, structural engineer is required wherever there is a bridge or any river crossing. So please imagine, now also in Chennai, we are having a Chennai to Bangalore highway. We can reach in almost with that high speed corridor, we can reach in 2.5 3 hours, we can reach. So that much highways projects are also getting up. Okay. Many highways projects I have written. In that I have written Bangalore to Chennai Expressway, a new access control road to improve connectivity between these major southern tech hubs. Many places I have mentioned it. And the green hydrogen mission, as I told you, in green hydrogen also, our investment is huge. It is almost 19,744 crore. Can you imagine 19,744 crore? So for which purpose it is there, 19,400 crore? You can see global hub for producing, utilizing and exporting green hydrogen. The mission targets 5 million metric tons annual production by 2030. So can you imagine? Now, what is the process behind this hydrogen? How we are going to make this? How we are going to do this one? Mainly through the electrolysis process. Okay, in the heavy water that is already in nuclear plants, there is a heavy water stream is there. That is, in that, if we separate that particular oxygen through electrolysis process, we can separate the hydrogen. Then that hydrogen can be stored. Okay, this hydrogen is collected at the cathode and oxygen at the anode. Okay, this main electrolysis process is being mentioned here. Okay, what is the purpose of this green hydrogen? The purpose of this green hydrogen is to mainly for the power generation. Okay, hydrogen based plants. Okay, the hydrogen will be used as a fuel to produce the mechanical energy. In turn, it will help to provide the electrical energy. So that is the main objective of this green hydrogen. Okay, its production process there and how it can be utilized also. Okay, now you can see here industry focus. Industry focus priority sectors for deployment include steel, shipping and mobility, infrastructure and hubs. Key objectives. The mission intends to reduce reliance on imported fossil fuels. Fossil fuel means coal-based. Okay. Main intention is to, mission is to reduce the fossil fuel means, that is as we are approaching towards the green mission by 2070. So this green hydrogen will help us towards that particular objective, especially in the power generation trend. Okay. Next is India's semiconductor mission. India's semiconductor mission is rapidly accelerating. That is, main thing is to build a strong semiconductor display ecosystem, positioning India as a global hub for electronics manufacturing and design, while serving as the nodal agency for the efficient and seamless semiconductor display schemes. So one thing is, you just imagine the amount of investment. As of early 2026, 10 major projects including FABs means fabrication and packaging units are approved with rupees 1.6 lakh crore in total investment. Can you imagine the quantum of, see all these figures, I am not just like that I am giving you, even some of the recent budget also I have seen, in that also this particular data is there. So all these are real data. Okay. One thing, so you just imagine the quantum of investment in the semiconductor technology. So not only in terms of design, fabrication technologies are also getting improved, and we are setting our own fabrication technology, self-reliant, to meet our industry demand, to meet our data center high processing chips, to meet our space missile chips, to meet our automotive electronics chips. So all these things we want to make it self-reliant. So definitely there are a lot of scopes for electronics and communication engineers in this particular domain. Okay. Now, projects 10 plus approach. You see the Tata Electronics, as I mentioned you earlier, Dholera, Gujarat, construction has begun on India's first commercial semiconductor fabrication plant, 91,000 crore project in partnership with the Taiwan, TSMC. Okay. And Micron Technology, that is almost $2.75 billion. Assembly and test facility is being built, expected to be operational by early 2025. Tata Semiconductor Assembly test. And one more thing, his HCL and Foxconn. This is now named India Chip Private Limited. HCL Foxconn joint venture, setting up 3,706 crore semiconductor outsourced, that is a plant near Jewar Airport in Uttar Pradesh, which I told you. Okay. So now this facility, what is the purpose of this facility is, this facility will handle 20,000 wafers per month, producing up to 36 million units per month. So can you imagine? Display driver chips for mobile phones, laptops, automobiles and PC. So they want it to manufacture it in India. They want it to fabricate in India. They want it to design it in India, make in India concept. Okay. And so definitely there will be a lot of scope for the VLSI engineers also in this particular domain. The facility is part of the India semiconductor, marking it as the country's 6th approved semiconductor, aiming at boosting domestic electronic manufacturing. So, by discussing about the various investments mission by India, now I have come to the conclusion. Okay, see this thing, these slides, if I can talk, I can also talk further also about these slides, but due to time constraint, I just restricted myself. In this, what I would like to suggest is, by seeing the quantum of investment, not only by the government of India firms, private utilities in India, as well as the foreign investments, that is, you need core competence as well as you need the data analytics skill, or you need the IT skills, or you need the data security skills, or you need the cyber. So all these things you need to apply for the core engineering to develop the society. That's what, as I mentioned, our country's GDP is going to improve by way of application of this data analytics in manufacturing and other various domains. So there are a lot of scope for this. So now what I'm suggesting is, now there will be a lot of students in there, that is those who are going to complete by 4th year now, they want to step in. I personally advise them, you please, whatever the core engineering you are studying, please write GATE. Please try to get qualified with please be strong with your fundamentals. The job opportunities will chase you. And those who are in CSE or IT background also, what I'm suggesting is, you try to apply your IT technologies in the core engineering. It will increase your market value. Okay, that's what I would like to say. So those who are, suppose if your siblings are studying in the 12th standard, or they're applying for the higher secondary examinations, then my best advice towards them is, you please, that is, there are plenty of opportunities in core engineering. As I told about the investment for civil, structural, that is not department wise, about the project wise, but still you need the engineers. Do we have for this much of investment, do we have the core competence engineers in the market? It's a question mark. I'm not telling it's not there, it's a question mark. Okay. So we must be the forerunner. I expect our prestigious, that is old, one of the old self-financing institutes in Tamil Nadu, our RMK Engineering College must fulfill the demand of the market by giving more core engineers to the society's development, country's development. So there are plenty of opportunities. You can advise the students, that is upcoming 12th standard students, to prefer the courses in civil or mechanical or electrical, and how they can apply it to the data analytics, because this data analytics course is being taught by the IITs as some of the programs, and even CDAC, DOE, ACC. There are some government firms, they also teach these particular courses. By that we can apply it, because once you apply this AI tools also, it definitely improves the productivity, but you must be in a position to infer the results and how to proceed towards it. So definitely core competence is required. So in this way, I am just concluding my session, and I hope this lecture would have been facilitated the upcoming engineers as well as the students who are studying. Once if I get an opportunity, definitely I'll come and meet you there in your campus also. Once again, I personally thank the RMK management, the professors, deans, honorable principal sir, faculty members, students, or all of us to share my knowledge with you for the benefit of India as well as for the society. I thank you very much. I'll definitely share this particular slides as well as the links also to your concerned professor. You can get it benefited with this. I thank you very much. Thanks for giving this opportunity. That's it.
Thank you so much, sir. You are very much invited to visit our campus. We are truly honored to have you. And we have one or two questions from our students. What one skill you see young engineers ignore but regret later?
No, I could not get you, madam. Please.
We have few questions from our students.
Okay.
One was, what one skill you see young engineers ignore but regret later?
What one skill that engineer
Ignore,
Uh,
but they would regret later.
yeah. Or okay, right. Actually, I don't want them to regret later. Okay. Now, whatever the branch they are studying, let them be confident with the fundamentals. Okay. Fundamental is very important. Whatever will be the branch they study, even if they study also CSE also, let them be confident with that. Or if they are core engineering also, let them be confident with the fundamentals. And most important thing is, as I mentioned again and again, Let them try to utilize the latest technologies. Let them try to apply how they are applying in the respective fields. That way, they must try to improve their skills. So that is most important. So the core, the whatever the engineering domain they are studying, they must study the standard textbooks. That is, they must follow some of the standard textbooks, even though study some PDFs and notes and other things. And they must be in a position, that is their respective tools or respective softwares. MATLAB is there, or any software, how they are applying it in their core engineering. That skill they need to develop. Okay, if they is only by gaining the IT knowledge, or only by gaining the core engineering knowledge, it is very, in this present situation, it is difficult to climb up the ladder. Definitely they can be getting jobs in the market, but the main thing is how they are applying the latest technologies into core engineering for for their operational excellence, whatever be the firm they are working, how they are applying it to achieve the excellence. So that skill they need to develop. Okay, that skill they need to do. See, in my college days, I used to study C, C++ and all. So now also that is fundamental, but there are plenty of other tools have come. AI tools have come. How we can apply it in that particular domain in core engineering, in electrical or mechanical or manufacturing, production or logistics or insurance, healthcare, whatever it may be, how we can apply it and how we can infer it. Okay, or in structural design also, how we can apply that one. So that particular skill they must learn. They must start learning now, and core competence is important. So if they are doing that one, they need not regret in the future.
Thank you so much, sir. And one more question, which one technology will dominate infrastructure in the next 10 years?
Definitely, I can talk about this metro projects and high-speed trains. First thing, that will definitely dominate. Second thing is this data centers. These two things. And third thing is this energy. Not third, I won't say third thing. When we talk about the data center, definitely power demand is there. That's why now our central power generating utility, that is NTPC, I like to quote now, NTPC, NHPC, and even this even private players, they have given to our engineering Maharatna company who manufactures this power. Almost 2 lakh crore orders has been received. Almost 2 lakh crore order. So can you that much of energy? Energy is one very vital thing that will be dominating in the future, because without energy or without power, definitely data centers cannot act. Okay. So power, and then data centers construction, and the most important thing is this transportation. Definitely this high speed trains, these metro projects, these three definitely will dominate. Data centers, of course, that what that paper clipping I have clearly mentioned. Data centers are getting developed, but how do we apply that application part? That will definitely come. These three things will dominate, madam. One is this power, there is energy. Second thing is this energy means I'm talking about the conventional renewables as well as the power transmission. Second thing is data centers. In that data centers also, second thing, first thing, and second thing, most important thing is this application of AI or IoT based applications towards core engineering. Definitely this will dominate. We are going for dark factories. We are approaching towards dark factories. China has already approached in some places. So dark factories means we need to collect all the data from the machines, and we must be in a position to operate. The production should run, but at the same time, human interaction will be minimum. So these things will dominate.
Thank you so much, sir, for the questions that have been answered. So now we would like to formally conclude our session. So I would like to propose a vote of thanks. First and foremost, we sincerely thank our distinguished speaker, Mr. Venkatesan sir, for delivering such an insightful and inspiring session, by encouraging students to prefer the core engineering platforms on par with the CSE and IT technologies. And we are truly grateful for your valuable knowledge and experience you have shared with us today. We also extend our heartfelt gratitude to our respective management, chairmen, and advisors, their continuous support, and to our respective principal and esteemed deans for their guidance.
Thank you very much, madam.
immense for your active participation. Thank you so much, sir. Thank you so much.
Thank you, madam. Thank you. Thank you.
Let us end the session. Thank you.
Thank you. Thank you, madam. Thank you. Once again, I thank everyone as well as the RMK management, principal, dean, all faculty members and students. Thank you very much.